So you know that feeling, right? You've just finished a great meal, you're feeling full, you're satisfied, but have you ever wondered what's happening on the inside? Because at that very moment, a super complex and amazing process is just kicking into gear. In response to that food, a master regulator gets the call. Its whole job is to manage that big rush of energy you just consumed and make sure everything stays perfectly balanced. That regulator, of course, is insulin, and its story always starts with a very specific trigger. And that trigger? It's a sugar spike. See, when you eat, especially carbs, your body breaks it all down into simple sugar, also known as glucose, and all that glucose floods into your bloodstream pretty quickly. That sudden spike is the alarm bell that sets this entire process in motion. Now, there's a technical term for this, and it's called hyperglycemia. But really, all it means is high blood sugar. And this is the signal. It's the body's internal memo that says, okay, team, we've got an energy surplus on our hands. Time to deal with it. The whole name of the game is balance. Your body works incredibly hard to keep your blood sugar in this very specific happy place, somewhere around 80 to 120 milligrams per deciliter. So when that meal pushes your levels above that, the main goal is to bring them right back down into that sweet spot. So who's in charge of detecting this sugar spike and launching the counterattack? Well, that would be the command center, the pancreas, a little organ kind of tucked away right behind your stomach. Your pancreas is a serious multitasker. It's got two completely different jobs. Its exocrine function is all about helping with digestion, but the part we're interested in today is its endocrine function. That's the part that makes hormones like insulin and releases them straight into your bloodstream. And this is what's absolutely wild. A whopping 99% of the pancreas is dedicated to that digestion job. This whole critically important process of managing your body's energy is handled by just a tiny 1% of the organ in these little clusters called the islets of Langerhans. Now, let's zoom in even more. Inside that tiny 1%, we find the real stars of the show, the beta cells. You can think of these as microscopic insulin factories. They produce it, they store it, and they're waiting for the signal to release it. So how in the world do these tiny cells know when it's time to release insulin? Well, it's not magic. It's a brilliant, super precise chain reaction, like a set of biological dominoes that get knocked over by that sugar from your meal. Okay, so it all starts here. First, glucose has to get inside the beta cell. It does this through a special little doorway called a GLUT2 transporter. As soon as that glucose is inside, the cell's machinery starts breaking it down to produce ATP, which is basically the main energy currency for the cell. Now, this is where it gets really clever. As the amount of ATP inside the cell goes up, those ATP molecules literally act like a pug. They go and block these little escape hatches that normally let potassium ions out. With the exits blocked, these positively charged potassium ions start to build up, and that changes the whole electrical charge of the cell. That change in electricity is the key. It acts like a switch that forces calcium channels to fly open, and suddenly calcium floods into the cell. This rush of calcium is the final, non-negotiable command. It tells all these low bubbles full of pre-made insulin, go, go, go. They move to the edge of the cell and release all their insulin into the bloodstream. And just like that, insulin has been deployed. So now insulin is on its mission. It's traveling all through your circulatory system like a messenger, carrying a very specific set of instructions for a few key parts of your body. Let's follow it and see where it goes. But first, one super important detail. Not all cells let sugar in the same way. The doors on your liver and pancreas are basically always open. Sugar can just walk right in. But the doors on your muscle and fat cells, they are locked tight. And insulin is the master key that can open them. This difference is absolutely crucial. Insulin's first big stop is the liver. Because it's so close to the pancreas, the liver gets hit with a really high concentration of this new insulin, and it gets its marching orders loud and clear. Insulin essentially tells the liver, hey, start grabbing all this extra glucose from the blood. Then I want you to convert it into a storage form called glycogen so we can save it for later. And while you're at it, go ahead and burn some for immediate energy. From the liver, insulin continues on its journey throughout the body, and its next big target is our muscle cells. Your muscles are huge energy consumers, especially if you've been active, and they're just waiting for their instructions. So, insulin arrives and does its thing.
It unlocks those special GLUT4 doors, opening the floodgates for glucose to rush in. That glucose then gets stored away as glycogen to fuel your next workout. But insulin is a multitasker. It also tells the muscles to start pulling in amino acids from the blood to build new proteins, so it helps you refuel and repair at the same time. The final major destination for insulin is our adipose tissue, which is just a fancier way of saying our fat cells. Their whole purpose is long-term energy storage.
Just like with muscles, insulin uses its key to open up the doors and let glucose in. But once inside a fat cell, the instructions are very different. The cell is told to take that glucose and convert it into fatty acids, which are then packaged up into triglycerides and put into storage for a rainy day. This is the process of lipogenesis, or literally creating fat. Okay, so let's take a step back. Insulin has delivered its messages to the liver, the muscles, and the fat tissue. What's the overall effect of all this hard work?
And here you have it, the bottom line. By telling all these tissues to either use that sugar or store it away, insulin has successfully cleared the excess right out of the bloodstream. That high blood sugar state is gone, and your levels are back down in that safe, normal range. Mission accomplished.
It's really an incredibly elegant system, this constant dance to keep our bodies in metabolic balance. But it does bring up a really important question. What happens when this system breaks down? What if the pancreas can't make enough insulin? Or what if the cells just stop listening to its message? Well, that's a story for another time.